Today, I'm excited to introduce our presenter, Ignacy Palau Rivera. He is the Executive Director of RAPID, and he will go ahead and take us through a project that he did with CII and share his findings with you today. Ignacy, thank you for joining us.
Thank you. Thank you for having me. Very excited to finally get to speak to all of you. Apologies for having had to reschedule this event at an earlier date. So my name is Ignacy Palau Rivera. I'm the Executive Director and Chief Technology Officer of the Rapid Manufacturing Institute. And I will present a little bit on background and present who Rapid is and who we are and how we came to work with CII and specifically with Jim O'Connor on a project that we sponsored and collaborated with CII and kind of the outcomes of it, some of the work we did, and where things are and where we want to take them, as well as some of the collaboration we did or came out of that with Dow. So Rapid, and you know, I wanted to keep kind of the title, our usual title, this idea of transforming the process industries through modular chemical process intensification is a bit of our tagline. And I'll present who Rapid is. And as you see here, you know, Rapid is really a collaboration, what we call a public-private partnership between the American Institute of Chemical Engineers and the Advanced Manufacturing Office of the Department of Energy. Okay, so the Advanced Manufacturing Office is part of the Office of Energy Efficiency and Renewable Energy of the DOE, and AICHE, the American Institute of Chemical Engineers, who I am both a member and an employee of. So Rapid is a part of AICHE that manages a grant, an agreement, a cooperative agreement from the DOE to do work. And as part of that, we are in charge of building and managing a self-sustaining consortium to bring these public and private organizations to work in the topic of process intensification and modular process technologies to enable, as it says there, a more resilient, lower cost, and reduced energy footprint for manufacturing in the process industries. So what you see there are those hexagons as some of the metrics that we were given by the DOE that we've been working towards for the last 5+ years in terms of increasing energy efficiency and energy productivity, reducing module costs, and the like. So why was a DOE and what was AICHE interested in working in this area? Kind of a bit of a background, and I'll try to go through this a bit fast. I think it's relatively easy to understand for those of us that have been in the process industries for a while, to understand that the manufacturing sector and within it, the process industries are a very large user of energy, in this case in the US, right? So manufacturing center about a quarter of total US energy use, with the process industries being the largest specific sector in manufacturing. So AMO, the DOE recognized the potential for MCPI, this modular chemical process intensification that I will define in a minute, and set up a Rapid or the initiative that became Rapid as an institute, and realized that the process industries, there was really no organization that combined tools, knowledge, experience, leadership, and act as a convening body. So Rapid became that convening body, and we have been in operation since 2017 doing just that work. Also, when we talk about the process industries, I wanted to emphasize that we're talking a bit broader than the strict kind of chemical and refining industry. We are talking about industries incorporating things like metals, pulp and paper, wood, construction materials, food, glass, and cement, food processing. In general, everything that is based on integrated flow systems as opposed to discrete products. Um, so very critical that we are looking at these wider industry manufacturing sector. So Rapid is a membership organization, um, similar or parallel to what CII is in that sense. Our membership is made of organizations, not of individuals. You see here a snapshot of our current, or at least current as of a few weeks ago. It changes a bit, as you can imagine, of the 2022 Rapid member community with the different levels of membership. I wanted to bring this slide because I am sure that there is many of you here who are attending as involved in CII that are actually in one of these Rapid membership organizations. We know that there is many companies that are both members of CII and members of Rapid. Many times the folks within those companies that are engaged in the different consortia are quite different, and there is sometimes not a knowledge or not an understanding that there is so much common membership. As you see here, Rapid has different types of members. We have industrial members at different levels, and large companies, medium companies, small companies. But we as well have academic and nonprofit and national lab members, as you see here. Affiliate membership is those kind of being engaged but not quite as integrated in Rapid. So obviously, any of you in these companies or other companies that have an interest in what Rapid is and what Rapid does, feel free to reach out. If you're already a member of Rapid but you don't know who to contact, our website lists the member representative for that specific organization, or we can help you find out so that you can work with us a bit more. Some of the regular member engagement opportunities, I have to put in a plug for Rapid membership, even though this is not really the focus of the talk. We are a community convener. We have our own series of events. We just started a Rapid Deploy conference series, which is kind of a hybrid between a workshop and a conference. Very interesting concept. A number of technical tools and resources, Rapid Test Network, software toolbox that we share with the members. Very strong and very highly praised educational and workforce development activities, some presential, some virtual online. And then collaboration work on technical projects, which is how the collaboration between Rapid and CII was established and performed, and I'll get into detail a little bit. So I wanted to spend a couple of minutes here defining this idea of modular chemical process intensification, what I sometimes call our sandbox. So this is kind of the original area in which Rapid was established to work in. MCPI for short. This is the combination of two concepts that have been and are familiar to a lot of chemical engineers, and the module, I would say, to others as well. But I wanted to kind of bring up the two concepts and then how we connect them and how we see extra value when that connection is done. So I'll start with process intensification on your right side of the slide there. So process intensification is a concept, an idea in the chemical engineering world, has been around for a while, is hard to define, is really one of those difficult to define ideas, but it has a fairly well distinguished personality. From the Rapid side, we look at it as a way to rethink process and process development, process design to dramatically improve performance. This idea of dramatically make huge gains in energy and capital efficiency, for example. Important point, the shift from separate unit operations, the paradigm of kind of stringing unit operations to make a process, to a more integrative definition or design of processes in which we combine the phenomena that normally occur in separate unit operations within these integrated, these intensified operations. Very basic example would be the transition from a batch process to continuous process. And one of the case examples that our collaboration address was very much in that area. The cartoon you see there at the bottom is one of the classic examples of process intensification. That's the intensified methyl acetate process that Eastman Chemical created or did. You see there the original process, many different units, many connections that was intensified into a single unit, into a single reactive distillation unit. So what you see is one unit instead of many, a more complex, a more integrated unit, but a much more efficient and energy capital efficient. So this is what process intensification is, or how we address it. Modular processing, also a number of different concepts that folks have done in the modular processing world. The way we look at it from the Rapid perspective is this idea of rethinking systems to enable flexible and distributed manufacturing. So we are looking at complete modular systems, not the Lego approach of many pieces into many modular pieces to make a larger process, but more of a smaller, repeatable processes so that we can go from a paradigm of a bigger is better, so the scale-up traditional approach in the process industries and chemical engineering, to the smaller modular paradigm in which the scale is not done in volume but in numbering up. So we go from a larger units in order to take care of economies of scale into numbering up of standardized units of modules in which there is no need to re-engineer each cases. So when you combine these two ideas, process intensification, modularization, into the MCPI, you can, and we have examples, and that's what we want to talk to you about, that can show a large increase in profitability from concepts such as faster build, increase efficiency, compactness, increase in quality, safety, lower maintenance, lower capital costs. And we'll bring up some of the examples that give rise to these potential increase profitability. In Rapid, we've been organized for a while now into a number of focus areas, some looking at application verticals in the industry, some looking at cross-cutting fundamentals. And I wanted to bring this organization because the way that we came out to work with CII in the project that I will present just in a minute, I came from very much one of these focus areas is focus area, the sixth focus area that you see here in Rapid, that's kind of focus area 10, which is module manufacturing, in which this idea that in order to take advantage of modular production, we need to better understand the costs of fabricating, designing, and then the repeated fabrication of modules, this numbering up. So within this module manufacturing focus area, we started a project, which is what I will present here, looking at understanding the cost of really scaling up via MCPI, via a numbering up of modular intensified units. Okay, so modular manufacturing focus area sponsored this project, and the project was performed as a collaboration between Oregon State University and their manufacturing engineering folks and the Construction Industry Institute at University of Texas. So the co-PIs for this project were Brian Paul from Oregon State and Jim O'Connor from CII University of Texas. And both of them presented at the CII meeting in Orlando last year. So some of you might be familiar with some of the work that they presented when it was roughly done, but not quite, maybe 90% done. The idea for the project was kind of trying to get some data and some case studies to justify these conceptual notional charts that you see here in this slide. So the idea that, for example, the one you see here, module produced versus volume produced versus number of modules or investment, gives you an idea that through MCPI, we can scale up production that allows us to go to a large enough production in a more, as I say, scaled up in a more gradual way. And what you see there on the right is that from a net present value, so from an investment, return on investment type of approach, a modular way would allow us to get scaling up with reduced initial investment, so a more gradual investment to the larger scale. So to prove these ideas, to prove these concepts, we set up this project and started working on it. This slide describes the project objectives. So basically raise awareness and really understand the benefits and drawbacks of these two approaches. So the MCPI approach as compared to the conventional or stick-built, conventional stick-built. So we use these two acronyms going forward, MCPI, CSB approaches for chemical plant construction. Really compare, contrast the actual economics of 4 case studies of MCPI versus CSB versus conventional stick-built, and compare the results versus the perception of the benefits and drawbacks. So people have a lot of ideas and a lot of thoughts about, in both camps, I would say, in the MCPI and the CSB, but the real amount of data and real case studies based on data is somewhat limited. And we really wanted to address that. Let's put some numbers, let's put some studies behind these perceived benefits and drawbacks. So to do that, the performance, and I would say Brian and Jim, with the help of the Rapid leadership and some of the community, we put up together a slate of 4 case studies that you see here, trying to cover a number of areas of the process industries. So in this case, case study number 1 was looking at a batch to continuous transformation. So large batch processing as the conventional case, going to a modular continuous approach. So that was intensification with the motivation of a reduced capex. And Jim will talk on that case study in a minute. Case study number 2, which was a bit of a tricky one, was looking at more of the idea of a distributed energy resource, and that one was a bit of a more difficult one, because there was no the capex data existing for it was at a slightly different level. And I'll let Jim and Olivier bring it up that a bit more detail. Case study number 3 that I will talk a bit later was kind of more of a distributed commodity production, so more of a traditional large chemical, and how to compare the more centralized scaled up approach that we've all had for years versus these modular distributed and that idea of numbering up. And then we had the 4th one, which is a distributed or a catalytic, a natural gas processing, trying to address processing distributed non-conventional natural gas. So different cases, different approaches. We'll get into detail in a couple of them, particularly 1 and 3. So I'm going to pass the voice to Jim O'Connor at University of Texas to present case study number 1. So Jim, take it away.
Thank you, Ignacy. Thank you very much. Yes, this is Jim O'Connor from the University of Texas at Austin. And as Ignacy mentioned, I was one of the co-PIs on this project that was all about case studies. So I'll go over case study number 1. And also, as he mentioned, we're always looking at MCPI versus conventional stick built. So you'll see that when we start doing comparisons. For case study number 1, the perspective is from that of the manufacturer operator. The driver for geographical distribution was customer location. The market specifically is specialty chemical. So in that regard, think low volume, relatively speaking, but high value. So very high value product, but not one that's at a commodity level, for example. The PI innovation was OTS, that stands for off-the-shelf tubular reactor, and a conversion from batch to continuous. So the conventional stick built will be a batch approach, and we'll compare that to an MCPI approach. Client motivation, primarily CapEx, but you know, clients are like kids in the candy store. They like a little bit of everything, and you saw that figure that Ignacy just reviewed. Plant size reduction for this case study was just out of sight. The CSB volume, conventional stick-built volume, was about 250 times that of the MCPI volume. And obviously, that represents a lot of material, a lot of piping, a lot of electrical, a lot of structure. So yeah, you're going to see some pretty shocking economic numbers that pair with that as well. Phase of assessment was about 1 year post-pilot, so relatively recent. And then as far as numbering up goes, numbering up was not particularly applicable here, but what we call design one, build many was. And so the economics of engineering at one time come into play in that regard. Next slide, please. So here's what we call the project frame and basis for some comparisons between conventional stick built and MCPI. With conventional stick built, we're talking about a 2-day batch mode. That's a 2-day cycle, and in contrast to a continuous approach with MCPI. The conventional stick built involved a 12,000 gallon stir tank reactor, and in contrast to a tubular reactor, which is sort of an all-in-one solution, not unlike what the example Ignacy provided a minute ago. We then have some heat numbers here. In a batch cycle-based approach, you know, you're turning it on and you're turning it off. So you have to heat it up and then it cools down, and then you start over again. That's all a little bit less relevant in the MCPI continuous approach. You can certainly see the heat loss numbers were minimal. And if you look at the heat transfer area numbers, you're starting to see the impact of process intensification. And that's a factor of 16 right there, 628 versus 39. So that's remarkable. Then you realize that, you know, when you're done with a batch, you got to clean it up, clean up the system and get it ready for the next batch. So there's flushing, there's purging. That generates waste, and that waste has to be dealt with. It's not applicable for MCPI. And lastly, with MCPI, because of the scale issue, we could rely on air cooling rather than water cooling, which involves, you know, a lot more hardware. Next slide, please. So, as I said, the the spatial volume difference was radical. So if you look at the green box, that's conventional stick built. You look at the little white brick in the corner, that represents the necessary volume for the MCPI approach, and that's a 250x factor there. The other thing I want to point out is that brownfield SimOps safety impact goes from very high in conventional stick built to pretty minimal for MCPI. SimOps, of course, being simultaneous operations. This is where you've got construction going on at an operating plant, and everybody's kind of on high alert because the risks are much higher, safety risks. Next slide, please. So we'll jump to CapEx here. On total installed cost for conventional stick built, $3.5 million versus $0.45 million for MCPI. Engineering cost $350,000 to $55,000. So quite a radical shift there. Next slide, please. Here's a comparison of how much time it took. So this is measured in weeks. These are all the various project phases. And you can see a reduction from 74 weeks with CSB to 22 weeks to get to production with MCPI. That's a 70% reduction. Now in construction, time is money. And you just cut 70% of the time off, you're going to save a lot of money with that as well. So that helps explain some of that cost delta. Thank you, Ignacy. Next slide. These are some an overview of economic metrics. So we've talked about CapEx 87% lower, NPV almost twice as high, the payback period 80% shorter. And then if you look at OpEx issues, operations and maintenance full-time equivalent go from 9 to 0.8. Power and utilities, 40% less. So you weren't turning it on and turning it off. It stays on. And kind of the roll up on OpEx itself, 14% lower. The only reason it's not more than that is because the cost of feedstocks was quite high for this product. Next slide, please. From literature and from interviews with industry, we identified 55 drivers of cost or some other benefit and presented these to each of our case study project managers, and they identified the ones which they felt were most relevant, most significant. And these are the top 6 drivers for this particular case study. So we're not generalizing this across all MCPI applications, but we're saying these are applicable, highly applicable for this particular case study. So PI equipment, smaller, cheaper, available off the shelf, lower weight, simpler, lower cost foundations and support structure. As I said, the reduced installation time and the SimOps that comes with that, earlier recovery of investment, unit productivity rate improvements from module fabrication. So it's a kind of a classic benefit from shop fabrication. And then pre-shipment testing of modules enhances performance assurance. So more likely that things will work when you get it out in the field. Before I hand it back to Ignacy, I just want to mention a couple other points that are included in the report, by the way. The final report, it's FR-373 for those of you that are CII member with member companies. The first point to make is that we found that given the high profitability of this particular product and the low CapEx cost of MCPI, that it actually makes sense to invest in a second redundant backup unit just in case there's downtime. And those economics were highly favorable. The last point I want to make comes back to the process safety issue associated with hazardous fluids as indicated by the quantity of fluids. And so we talked about that 12,000 gallon reactor. The size of the MCPI approach was about 30 gallons. So that's a 400x reduction in risk exposure. So with that, I'm going to hand it back to Ignacy, and he's going to talk about case study number 3.
All right, thanks, Jim. So case study number 3 is a bit of a different beast, really. And you know, case study number 1 is one of those that is a real eye opener because of the huge benefits that the MCPI approach shows. Case study number 3 is really one of those that the preconception is always that for a commodity chemical, for a large volume a chemical, a centralized, what we call that CSV, that conventional stick-built approach, should be better. It's expected to be better, right? So let's put some numbers behind it. And what you see here, both the MCPI and the CSV approaches, in this case, is continuous. The issue becomes on number of trains versus capacity. Obviously, on a centralized approach, the way you get capacity is by having a larger plant. On an MCPI approach, you have more trains, right? Still, you have that advantage of the deployment schedule on the MCPI size. Being able to get to scale in a more step-by-step approach, which allows you to get to some scale faster. In this case, obviously, the operational lifetime and rate of return were put at the same level to be consistent and to have a bit of a fair approach. I will jump directly into some of the CapEx and OpEx comparisons with these plots. On the CapEx side, what you see is sort of what should be expected, right? Which is the MCPI approach, which is the blue line in there on the left. It's a gradual increase, right? The more trains you have, the more it goes up. So you have a bit of a linear increase with the number of trains. While in the stick build, what you see is a curved approach, a growth, but it kind of peters out. So right, the more trains you have, or equivalent trains you have, the lesser the advantage of the MCPI approach. So clearly, on a CapEx perspective, if we're going to have 1, 2, 3 a number of trains, there is an approach, there's an advantage, a clear CapEx advantage at going at it from a modular intensified approach. At 4, I would say you're sort of getting close to equivalent, and 5 is really, cross the other way. And if you were higher than that, the stick build, the centralized approach, clearly starts winning out. So this is what we conceptually we would be expecting. In this case, that crossing of the lines is in that, roughly 4.5 idea, so that we see that there is a good range for production capacity at which MCPI has an advantage before the stick build takes over. Looking at OpEx, you see something not too different, but it's important to look at not just the total normalized OpEx, but also what goes in there, right? So when you look at utilities and raw materials costs, so those variable costs, what you see that's obviously kind of proportional to the capacity, so that there is no real advantage or very small difference between the two approaches. You see there the roughly the changes. There's no change in capacity between both of them, and they're slight advantage to one of them. When you start seeing more of a difference, it's on fixed costs, right? So fixed costs, especially on the labor costs, for underutilized larger plants, the advantage of the modular becomes higher, right? So that idea that it allows us to scale up more stage by stage means that we don't have extra labor because we have a centralized plant. So we put capex and opex together in a more total economics and total production costs. We see what we would expect, right? So that for lower number of trains, and in this case, the cross point for the combined is roughly at that number of four trains. There is an advantage of MCPI. The more trains you have, the advantage of MCPI, so lower capital recovery or production costs. You see the shape of both curves being virtually identical. So production costs, an advantage of MCPI until you get to that four number of trains in which you get basically equivalent. And crossing that stick build, the centralized approach starts being advantages. So what are the MCPI drivers that we see from those results? So the reduced construction footprint makes a sizable reduction in the initial capital investment, right? So that initial investment is much less. You don't need to have, because you're able to do that module by module, you don't need to have the whole capital available at the beginning, which gives a clear advantage. The cost reductions, especially on the CapEx side for the PI and modular technology for the MCPI, are really driven by the interconnecting system, by piping and similar wiring type of approaches. And then we also see that a lot of the advantages come from that shortened deployment schedule that Jim referred to before. So the ability to do parallel and concurrent module fabrication and assembly really helps, right? You can do it, you can build the different trains at the same time without having to have an all or nothing type of approach. So from an overall project, and this is going beyond case 1, 2, 3, 4, when you put all of them together and kind of look at the overall conclusions, this is kind of the main conclusions that are spelled out in the report that Jim just made reference of to, and I'll talk to a little bit later as well. So PI technology, so that the intensified side, not yet the modular, really reduces plant size, right? And that's a critical point. Intensification really enables modularization. A modular approach without an intensified technology is a very limited scope. So intensification enables modularization, reduces construction scope, reduces time to market, and really accelerates the capital recovery, right? We start producing and getting revenue quicker, so we start paying off the capital quicker, and that's a huge advantage. Operating expenditures are also reduced in MCPI plants, mostly from being able to use less operating staff in very much that batch of continuous or reduced number of operating steps when the intensification leads us to that reduction of operating steps. Batch to continuous is really a key opportunity for MCPI to show its full advantage, especially reducing capex and time to market. You saw from case study 1 that Jim presented the huge advantages for those types of opportunities. The cost of process intensification is an important driver. So it must be managed appropriately. And there is a number of conclusions, more detailed conclusions if you read the report, in which it's important. For example, I'll bring one of the ideas, which is go after off-the-shelf technology or off-the-shelf equipment when intensifying. Custom-built equipment, custom-built is always more expensive, and it can eat off some of the savings. So important to understand where the pressure points are, where the advantages of both approaches are, and then take full advantage of them for the cases that they are appropriate. So I wanted to kind of go towards the end of the presentation and then pass it on to Olivier. This is the report that Jim made reference to, final report 373 in the CII world. This is available to both CII and RAPID members, and we decided to create a single final report that would be a kind of the final report from both collaborating institutions here. You see the link that is hosted for those of you that are members of CII and those from RAPID. We can help out. I also I wanted to highlight a number of the other what we call project products. So these are mostly publication reports and other that have come out of this process collaboration. So beyond this in-depth report from CII and RAPID that we just presented, as I mentioned before at the end, there Jim and Brian presented at the conference last year. There is also an article that Brian, Jim, and Carl Hapala from OSU as well wrote in CEP. CEP is the magazine that all AICHE individual members receive, so March 2021 available. And then a number of peer-reviewed publications, mostly in the Journal of Advanced Manufacturing and Processing, which is a widely publication and is the official publication of the Advanced Manufacturing and Processing Society, a community of AICHE. So this is a peer-reviewed publication. A number of these 4 articles or papers have been already published, and I think there's a pending one. So those of you who want to look at details on the cases, you know, number of things that can be looked at. So I'll move it on to Olivier, some thoughts on CapEx, and then close up with some high-level conclusions. Olivier?
Yeah, thanks, Ignacy. So yeah, I'm Olivier Lenormand, working at Dow Chemical as a global improvement leader, and there I mostly look at you know, modularization in our CapEx portfolio. So what I'm going to talk about here is just another aspect of this study that was led you know, by Jim. I came in this study as a member of CII and tried to help you know, the best I could. I just barely have enough knowledge to be in this webinar and present what I'm going to show you here. But in summary, the team developed a cost estimate that I think can be useful for owners, but as well, you know, engineering companies, EPC companies, to evaluate the value of MCPI at this time when you don't have enough data on a project yet, and you want to know if you are going or not to develop modular, but maybe modular and process intensification. Really a key element here. So this MCPI 2021 cost model was developed in the frame of this effort here, and you see a table here showing how it was developed, what are the main characteristics of this cost estimate, and it is compared to another model that apparently the research team was let's say, benchmarking against. That used to be one that modeled the cost for the impact of applying modularization only, which is Sievers. Model type is bottom-up and top-down probabilistic model. So to me, that means it's based on, it's a factored approach, if you want. So again, high level, and I think it applies to FEL2 level estimate, maybe FEL1 as well. For everyone, FEL means front-end loading, and FEL1 is really about project definition. FEL2 is when you start to define your scope. So you see the different elements that are part of here. I think on element 3, correction factors, which is really where the know-how was put. It's a factor that are applying, whether you apply process intensification, modularization, and numbering up as well. So there are a set of different factors for each of those elements. I think we can go to the next slide. Yeah, I think that's thank you. So we participating in this research, we were asked to try to do two things really. What is the allocation of CapEx, and we looked at OpEx as well. What is the allocation of CapEx within different categories, which you see on the column on the left: engineering, procurement, fabrication, field installation, and all that. For conventional stick build, so that's the two other columns, and with a min and a max, which gives you this probabilistic approach as well to the model, and then have the same allocation distribution for MCPI, which are the four last columns, and you see the distinction between one train or the first train and then the following trains when you do number up. So different allocations, and really what before showing the next slide will show you the correction factors for the impact of modularization, process intensification, and numbering up. But what you would do is, if you know your CapEx for your conventional stick build for the facility, then you can take this number, break it down back into either MCPI one train or MCPI different trains in the way it is shown on this table, and then go to the next table. Thanks, Ignazi. The next table, next slide, which shows the adjustment factors that have been determined by the research team and input from different SMEs and people from the industry, CII members. And here, this time, the correction factors apply to those different B1, B2, B3, B6 categories. And then you would have an estimate of the CapEx for your MCPI project, which I find beautiful. Now, the question is, does it work? So the research team didn't stop the effort here, and going to the next slide, they have tested their model against those case studies that you have seen, which are real case studies and for which they have the actual cost. So on the left side, you see project 1, 2, and 3. I'm not sure they correspond exactly to case 1, 2, and 3, but I don't think that's the purpose here. But you have the conventional stick build value against which we make the comparison. And then you have in green those min and max for the MCPI using the cost model I showed you on the two tables before. And you can see how it compares to the right column, which is actuals. And looking at that, I mean, you would see that it's really not that bad. And honestly, I didn't think that would yield such good results, but I think it's pretty good. And kudos to the research team for having done that. I think that can be a useful way of approaching the question for the industry and to decide whether or not you should go or not with MCPI. I think it's a good start. The next slide shows the level of accuracy obtained with this model. Blue is for the other former benchmark cost model, but in orange you see for different projects how the cost model accuracy was against actuals, and you see the 34%, 25% for project 3, and 30% accuracy for project on overall. One project was a little bit off, but of course, everybody needs to understand that there's no one model fits all, one solution for all. But I think those correction factors can also be tuned depending on a specific project, and it was a pretty good result, I think. And that's all I had to share on that. Back to you, Ignacy.
Thank you, Olivier and Jim. I think it is just kind of the end of the presentation. Thank you all. I just wanted to give another plug, but we would like to continue some of these work. We have these 4 cases, as you saw. They're somewhat scrubbed from identifying data. They're all are real cases in which there were, the data was collected through interviews and through, work and collaboration with the companies involved, but the presentations, the sharing was scrubbed of that. Some of them are more or less identifiable. We would like, and Jim reminded me yesterday of that, finding a 5th and a 6th case to potentially have a wider coverage of the process industries and the different cases, and really understand the potential value and plus and minus value of these modular intensified approaches for new plants or for brown and greenfield. So if you guys are interested, anybody, contact any of us, and we will work with you. We will try to figure out how to best incorporate it. So thank you. I think we have a little bit of time for questions, but
yeah, Ignacy, if you could advance to the next slide, that'll give the contact information for folks to reach out.
I think I had some final ones. I don't see the final.
I think the very last slide had some contact info. Maybe not. I apologize. Well, I am not showing any questions.
Yeah, there we are.
Oh, there it is. Fabulous. So if you guys do have any need to contact Jim or Ignacy or Jim's assistant here, you can certainly approach them via those email addresses. We'll get you in touch with Ignacy as well. I am currently not showing any. Oh, we do. We have a question here. Did you study any brownfield projects?
Yes, we did. I mean, technically speaking, the case study I went over was brownfield, and that this little plant, this specialty chemical plant, usually sits in the context of a larger plant. So that qualifies it as brownfield. The same is true of number 4. And I think number 3 can vary either way. Number 2, mostly greenfield.
Okay, I have another question. Can you share more about the emergency case study that was studied?
Emergency case study.
What
is the reference to?
Well, that's all I show there in the question. Can you share more about the emergency case study?
Emergency.
Nope.
Yeah, I don't think any of our case studies fit into the emergency.
Okay, well, the question came from Jason. So Jason, if you're still out there, feel free to follow up with Jim directly on the email address that was shared. Otherwise, everyone, that was the last question I had. I had some positive feedback from some of the attendees today. They said thank you for all the great examples. Thank you all for your time. We appreciate your attendance today. Again, feel free to reach out to our team if you have any follow-up questions. We are more than happy to circle back with you after the fact. So thank you to our presenters today, Ignacy, Olivier, and Jim. Great information to share with CII's membership today. We will return you all to your day, and we thank you again for your time.